Welcome to A-level lesson all about surds. Hopefully you've joined me because you want to make sure you've improved your surds. You want to make sure you can use your surds for all the things in year 13. Maybe you're a year 12 who's done it but who still makes mistakes with it. Maybe you're a year 11 who's trying to touch it up, because obviously there are some surd elements to the GCSE as well. This is a GCSE higher topic that has also spills over into the A-level. Or maybe you're just wanting to make sure you refresh and make yourself better. Well, hopefully in the next, I say 20 minutes, we're going to go through some surds questions that hopefully will make it easier for you, make it so you can understand it better, and hopefully by the end of it, you'll have a better understanding of how to perform surds. So in order to do so, let's just get going on our first point. I've got the surd root 88 here. Root 88 simplifies to root 4 times root 22. And you can see the solution steps going on here. That 88 is 2 squared times 22. So we can therefore rewrite it all as 2 separate roots, which I've done there, and then simplify the root 4 down to 2, giving you 2 root 22. And we can do this with any number. Let's say I start with a root. Deliberately, we start with root 100, not 196, because we know that's a square number, with a root 100 and, let's just rub that out, 147. When I look at 147, I'm looking for factors, and fortunately, it has several. It does divide by 3, so we could write it as root 3 multiplied by root 49. The reason that's useful, not because of the 3, but this number here. Because root 49 is a square number. So 49 is a square number, so root 49 is going to be 7. So we can write this as 7 root 3. We also have to be aware of never wanting a surd on the bottom. That means if I have something like 12 over root 2, I instantly have to be filled with disgust. Ugh! It's a surd on the bottom, and we do not want that. So the first thing we're going to do is we're going to try and replace that with something that's going to be useful. So we're going to multiply both the top and bottom by root 2. We're allowed to do that because all of the numbers in there cancel with each other to make 1. You may always multiply by anything if it makes 1, because you're multiplying by 1 and nothing changes. Sorry, Isabella, I will slow down. And hi, thank you for coming in to watch. I'll slow it down a little. Thank you for your feedback. It's all very useful. Hi Lumi. Now, what we're going to do is, in order to work this out, we're going to do 12 lots of root 2 on the top. But when you multiply root 2 by root 2, you get 2. It is the way of undoing root 2 times root 2. So here we have 12 divided by 2 gives us 6 root 2. What this is saying is 12 over root 2 is equal to 6 root 2. And we always are looking to do this. We are always looking to rationalise the denominator. And we want to make it clear that that's what this is called. Rationalise the denominator. Now at A-level, they often, in questions, sometimes I'll use this phrase, but often they like to use ways of getting you to do it without saying this is what you're going to do. Some of those words are simplify. Sometimes it's more a case of leave your answer as, or leave your answer in the form. Because rationalising the denominator, because it's been requested, when you say root, do you mean the square root? So absolutely. So root 2 is the square root of 2. If I mean anything other than than square root, I would say cube root or third root or to the third root. So whenever I just say root, I'm meaning square root. So if I've got something like 15 over root 3, I know immediately I want to get rid of that surd on the bottom. Not because it's told me to rationalise the denominator. I just need to program myself that I hate it. I hate it with having a surd on the bottom. It disgusts me. It makes me feel absurd. No apologies. So we're going to multiply it by root 3 times root 3. Therefore I end up with 15 root 3 over root 3 times root 3 just gives us 3. So we're going to then simplify. 15 divided by 3 gives us 5 root 3 because the 15 cancels with the 3. And we have simplified and removed by dividing down. Hopefully that's useful. Okay, I'm just trying to check it infrequently if there's any questions. Now, what we're going to do with that is some questions that are as an exam type question. Hopefully that's big enough that you can all read it on the screen. I'm sure you'll let me know if it isn't. So this is a typical exam question. They have said, write root 80 in the form c root 5 where c is a positive constant. What they're basically saying is rationalise the denominator or simplify the surd. In both these questions, they're asking you to simplify things. So this question is about simplifying. So let's do so. Root 80 has options. It could be root 10 times root 8. Problem is, neither of those numbers are square numbers. So it's not a useful one. But it is also equal to root 16 times root 5. And this is far more useful because we have a square number as one of the factors. This means I can rewrite it as 4 root 5. But the question says write it in the form c root 5. So therefore it might be worth, this would get you full marks. But I would normally say at the end, so c equals 4 as well, just to demonstrate your full understanding of the question. The second question says, a rectangle has length 1 plus root 5. Now, one of my bugbears is when I see people doing a question like that with no diagram. So my first step when I do this question is to draw a rectangle. I then know it has a length of 1 plus root 5, and this is so common in these sorts of questions. It's used the root 80 from part A. So I am going to instantly write 4 root 5 just here. Hopefully that makes sense to everyone. I'm now going to multiply for area. I know that the answer was 4 root 5, not the side. So first thing I'm going to do is make a correction before I get slaughtered by people for making a mistake. So I now therefore know that I need to simplify, which means the area is going to be that divided by that. Not for the first time today. I'm talking about inverse operations. I know that 1 plus root 5 multiplied by the width, which is called r, will equal 4 root 5. Well, therefore it stands to reason that r is equal to 1 plus root 5. No, it's not, Mr. Harris. Everyone's fallible. As you can see, my quote for the day is, I would never want to make a mistake once, or I never make a mistake twice. I make it lots and lots of times. So, 4 root 5 over 1 plus root 5. But this makes us feel ill. It's got a surd on the bottom, and we don't want that. So the first thing we're going to do is make sure we get rid of that by timesing by that exact thing on the bottom. We haven't yet done one where we've got a pair of things going on. But it shouldn't scare us. It is 4 root 5 times 1 plus root 5. And over here, we've got a double bracket. But what I'm going to do, to ensure this is made easier, I'm going to make them minus. Because I want this to get rid of surds. And one thing we know from our GCSE, but also from year 12, is if you've got x plus a times x minus a, it makes x squared minus a squared. And surds squared disappear. Therefore, by doing the minus version of the plus, we are going to allow it to disappear. So this one, we're going to have minus root 5. That is going to multiply as 1 squared minus root 5 squared. But whenever you have a root squared, they basically cancel out, and we've got 1 minus 5 equals negative 4. Over here, I've got 4 root 5 minus 4 root 5 times root 5. When you multiply root 5 by root 5, you get 5. So this should make 20. What I've now got, if I scroll down a little, I should have enough room just about to write that the overall thing here is going to come down here and be 4 root 5 minus 20 all over negative 4. But they all divide by 4. It's almost like they made up the question so that that would be the case. 4 divided by minus 4 is minus 1. And minus 20 divided by minus 4 is plus 5. And we've got, as I mentioned before, that would probably be enough for all 4 marks. But I'm just going to clarify that P in this scenario is minus 1 and Q is minus 1, P is 5. Let's see if I can. It's not the neatest working in the world, and I want you to all follow it. So we've got P equals 5. And there we have the simplified version. Any questions? You're both asking. This is similar to algebra, Abdullah. Yes. Why am I making it minus? Which one am I making minus, Isabella? When the question is times it. Okay. So I've got minus 4 because it's 1 minus 5. So then I've got minus 4, and I'm dividing by minus 4. So 4 divided by minus 4 is going to be minus 1. So basically an invisible 1 there. And minus 20 divided by minus 4 is plus 5. What we're trying to do, we're multiplying by the opposite sign because of our facts we already knew about. If I scroll up slightly, from GCSE we already knew that if you expand, it's called the difference of two squares. You just multiply by the opposite version, it will create two square numbers, and when you have squares around surds, that's what makes them disappear. So it's this process that's making them disappear. Let's do the next question, and then I'll see if I can make up any that anyone ask specifically. Okay, so it says express this in the form A. Sorry, I didn't do my reading exam question voice. Express brackets 5 minus root 8 close brackets open brackets 1 plus root 2 close brackets in the form A plus B root 2 where A and B are integers. Basically, multiply out the brackets. What colour am I in the mood for right now? Let's have some orange. So, we're going to multiply that by that. Easiest bit is going to be 5. Then 5 times root 2 is plus 5 root 2. And then negative 8 times 1 is negative root 8. And negative 8 times plus 2 is negative root 16. So we've got 5 plus 5 root 2 minus root 8 minus 4. And this is where we have to be a bit clever. We have to remember, wait a minute, 8 is 2 4s. So I'm going to rewrite that, and I'm going to do that over here. Root 8 equals root 4 times root 2, so it's equal to 2 root 2. For that reason, I can then write it out again as 5 with the minus 4 is 1, and this being 2 root 2, 5 root 2's take away 2 root 2 is 3 root 2. And I've got A as 1 and B as 3 for 3 marks. Any questions on that? Looks like you're following it. On this bit, we're doing express this in the form C root 5, where C is an integer. Again, just a whole number. So it's almost like saying, by the way, here's a clue to your answer. So what we're going to do, we're going to start with root 80, which just so happens to annoyingly be the same from the question before, and we're going to have 30 root 5. I like to do them separately. You don't have to. You can do it all in one go, but I like to rewrite that as root 16 times 5. Unfortunately, it's the same one we've already done. 4 root 5. At least it makes sense why we're racing through that one. And this one, surd on the bottom alert. As soon as we see a surd on the bottom, we know we're not having that. Okay, that's the root of all our problems. Again, no apologies. Equals, and we're going to times that by root 5 over root 5 is 30 root 5. But remember, when we times root 5 by root 5, it just becomes 5. There's my 30. And 30 divided by 5 is 6 root 5. So I've now got 4 root 5, add 6 root 5. If I was to ask a 4-year-old that question, they'd probably get it right. If I was to ask a 12 or 13-year-old, they'd get themselves in a state. Basically, 4-year-olds just would go, 4 things and 6 things. That makes 10 things. And that's what we do here. 4 root 5s and 6 root 5s must give us the answer 10 root 5. So C is 10. And we get our 3 marks. Any questions? Silent streamer, if you need to go to the toilet, you can always go to the toilet. You can pack up whenever you want to pack up. You're welcome to pack up whenever you want. Okay. That concludes all the stuff I have planned, except for the algebraic surds. Ugh. I know what you're thinking. What does surds have to do with algebra? Well, first of all, a quick brief reminder that x to the power 5 over 2 has an element of surd in it. It is root x to the power of 5. And that's important if we have things like this. If I have a situation where I've got 30x cubed over root x, I have once again got a situation where it's got this, it's got a surd on the bottom, and we don't like things on our bottom, for want of a better expression. So therefore we're going to times it by root x over root x, giving us 30x cubed root x all over x. Because when you multiply a root by itself, it undoes itself. Now the x cubed will cancel out with the x, dropping itself down. That will disappear, and that will drop down to 2. So let's write that down. 30x squared root x. But we don't want to have x squared and root x. So we want to have 30x squared, and remember that this root x is the same as x to the power of a half. Therefore, we've got x squared and x to the half. If you add 2 to a half, you get 2.5, or 5 over 2. So I'm going to rewrite this as 30x to the 5 over 2 referring me back to what I had when we started talking about it. That should have been enough of a summary. We've done 20 minutes with a summary of how to do surds and rationalising the denominator. This should help you with any questions you have involving them. I'm free to answer any questions in the comments for the next couple of minutes. I hope this has been useful. I don't want to keep people longer than the time that they need just because we have to stick to 20 to half an hour or anything. Hopefully that's been useful. I've been Mr. Harris, and hopefully you've learned some maths today. Let people know about it. Please feel free to email me at schoolofmrharris@gmail.com with any questions you have. You can use the Facebook group for School of Mr. Harris, where I will happily answer questions or you post. Or you can tweet me. A lot of sixth formers are far more used to using things like Twitter, and I'm at School of Harris. So at School of Harris will allow you to tweet me, and you can ask me any questions you have. Ask questions in the comments below the video for any clarifications or anything I've said. I've possibly made a couple of mistakes, we just don't know, but I hope it's made sense to you. Until next time, thank you very much for joining us, and I will see you shortly.